Today's episode is sponsored by Advex AI, delivering top-performing computer vision in hours. Visit them at advex.ai.
Aerospace and defense manufacturing.
Machines and automation.
Additive manufacturing.
Smart manufacturing.
The global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing.
Hello, and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. I'm David Muller, Senior Editor at SME Media, and your host today. We're joined by Pedro Pachuca, who is an entrepreneur, educator, and also the CEO of Advex AI. Pedro's background is in AI research with the University of California, Berkeley, as well as Google Brain, and building products at Google and other various startups. Advex's mission is to improve industrial efficiency by 1,000 times. The company is developing vision AI that can support the ever-changing and use case-dependent nature of the real world. The world of industrial automation is used to underperforming vision systems limited to very simple use cases due to the data-hungry nature of AI. But Advex says it's using generative AI to solve the data problem and bring vision automation to every factory in the world. Thanks for joining us, Pedro. We're glad to have you here. Welcome to the show.
Thank you, David. I really appreciate you all having me.
So, great. Now, maybe we can kind of just start from the top here. How did the idea to use AI for generating images to train machine vision models first come about?
Yeah, I mean, it's a pretty in-depth idea, but really for me, it started when I was responsible for setting up manufacturing for a previous company. And so I was the guy that flew to Shenzhen, flew to various places in Europe and Mexico where manufacturing is popular. And I was looking at the differences. There's just a huge difference. And I spent 2 months talking to manufacturers to understand why some areas were more automated, some areas were more manual. Where did the cost difference, where did the investment come from? And what I found out is that a lot of this automation is really high in ROI. They'll maybe put in 10 million, they'll get 50 million. It's a good ROI. But the payback period, the time it takes to get that ROI is just so long. And it's quite high for a lot of different areas. And only some of those areas can actually stomach that high ROI, a high payback period. And so what really the focus of this payback period, where all that time goes, is into training the AI. Because AI is, as you alluded to, data hungry. It relies on all of the data to learn, to be able to do what it needs to do. And often that process takes months, it takes years to get an AI system to production level. And at the same time, I was starting to get exposed at Google Brain and at Berkeley to these synthetic data ideas on how do we use diffusion models, how do we use the latest generative AI techniques to maybe tackle this data problem. And so for us now, we think that synthetic data could be a solution to that data problem, where it just takes so long to collect data. And you can't really do this off the shelf with a normal model. You need a bunch of different knobs. So that's what we're building today.
Excellent. And so now today, right now, who's using this? Who's using Advex system?
Right now, a lot of people are using it. Some of the largest machine vision providers in the world, some of the largest manufacturers in the world. So we'll go to auto, we'll go to aero, oil, consumer electronics, robotics, bunch of different areas. And it's very interesting how all these people have really the same exact problem. And even though we're a young company, we're a startup, these massive brands have trusted us because we give them what they want. They're able to get automation on defect detection, on visual guided robotics in a very short period of time. And really what we're solving for them is, okay, these big companies are coming to them and saying, you need to spend years, months to years collecting all the data. We tell them, here's how you can only take 2 weeks. And most of that benefit is going to two groups. There's the defect side. A lot of people are trying to find defects, but the defects are rare, right? These manufacturers are not trying to produce defects every day. And the other side is high variance use cases. So on the defect side, it's like, let's say like Toyota. They want to find defects in their car seats. Well, they're not producing defects. In fact, that's exactly the opposite of their job. So they might take years on years to reach that production level accuracy. And then on the other side, on the variant side, you can imagine someone like FedEx. And imagine all the things that you can ship with FedEx. So they have to deal with a ridiculously large amount of packages, all the different colors and shapes and sizes and orientations. And so collecting data for them that spans the entire distribution of what they care about is pretty hard. And so for me, I mean, what excites me the most is getting this into more people's hands, being able to make AI, make vision easier to use, and have it eventually be an off-the-shelf system. And I think that generative AI is really going to help us get there, where one day maybe we can just set up an industrial camera, point it at the defects or the parts that you care about, and it'll just work at production level.
Awesome. Okay. Yeah. And I saw some cool examples on your website, detecting like a car interior. For example, you mentioned some of your auto customers or car carpet, interior carpet. But can you maybe take a step back and drill a little bit more into how it actually works? How does Advex work?
Sure. So for us, Advex is really about the data. We don't believe that most of the gains in making a good AI vision model are in the architecture or other areas. With AI, it's only as good as the data that you provide it. And so what we did is we took these generative AI models, specifically diffusion. We made them scalable, we made them controllable. And the whole point of using diffusion models is that we can create images. So we are literally creating the data that these people would have collected if they put up a camera and just waited a very long amount of time. And for us, you have these knobs. We can generate a very large amount of images very quickly. I'm talking hours. And so you generate tens of thousands of images in just a matter of hours. And one important point here too is we're not just generating random images, right? We're making very specific images and more precisely, giving them the images that they don't already have. And so behind the scenes, what our system is actually doing is understanding what is this context? What is changing? What is not changing in this situation? What are these pictures of? What data do you need to make a good AI automation that you don't already have? And so we've enabled our models to produce those types of images that are necessary, and also the labels on top of them. That's also a really important part. If I just gave you a bunch of images and I didn't tell you, where the defect was in that image, it would be pretty useless to you in terms of making a model that can tell you where the defect is. So on top of the images, we also have the label. And to just guide you through an example, if you're an automotive company, you're finding defects on carpets, you set up your camera. A lot of people like to use Basler or Cognex or a bunch of different companies. And maybe at the end of a couple days, you have 10 pictures of defects. That is not enough to make a good vision model, but it is enough to use Advex to then create 10,000 defective images of all, let's say, those defects in different positions and shapes and sizes and lighting conditions. And after that, now you do have everything that you need to build that really strong detection model. And one interesting thing after that is if any of the listeners have done vision, it's something that changes all the time. Like if your lighting changes, your model will perform worse. And so it's this cycle, like, oh, something changed. Let me go back and collect more data so that I can update my model to my new environment. Well, the other piece where Advex comes into play is making that update a lot faster and with a lot less data. And so, yeah, the system is all about using diffusion, these generative AI models, to create an AI that works really well for, let's say, a new inspection point, if we're talking defect detection, and then in the future adapt it to new scenes, these lighting conditions, or other variations too, like color in your parts, a new supplier, things like this.
I really can just, within hours, start to detect a new inspection point, adapt to new scenes, like you said, in new lighting conditions. It's pretty impressive. So now, like, if I'm a manufacturer or a shop, how would I go about integrating Advex into the factory floor?
Yeah, the factory floor is a pretty complicated, hectic space. But what we have is a web platform. Any operator can use it, and they just upload the data that they can easily collect. And so for automation engineers, they might be familiar with Cognex Vidi or MVTech Halcon, Keyence VS. These are super popular all-in-one systems. And you can just take the data that these, let's say you collected with your Cognex system, upload it to the Advex platform, download then the bunch of images that Advex creates, and you put it right back into Cognex Vidi, and it'll do the training automatically. You don't actually have to treat any of the synthetic data we produce any differently than real data, right? It is just real data. It's just you didn't have to collect it yourself. And then there's the other class of machine learning engineers, people who are not using these off-the-shelf systems, but who have actually built the whole pipeline themselves. And for them, you can just download the data off the platform in Cocoa format, in YOLO format, whatever format they end up using, and put that directly into Google Vertex, Amazon SageMaker, maybe their own custom pipeline. So it's really just an upload and a download process.
I mean, is it kind of just, is it fair to me think of it as kind of plug and play pretty much? I mean, it depends, regardless of what system you're running, you can kind of bring in Advex and start generating the data that you want.
Yes. You just collect the data, upload it, download it, and you get going. And what we're doing too to make that easier is we're building relationships with those large machine vision providers so we can have even tighter integrations. And maybe one day you won't even have to download data off your Cognex Vidi or Keyent system. It'll just ping an Advex API and it'll be all done before you know it.
Can we take another step back here and kind of maybe just talk about what diffusion is and how it works?
Of course, diffusion it's a super interesting technique. It's actually not that old. It's only a couple years old. And there are different iterations of it. There's diffusion, there's denoising, probabilistic diffusion, and a few other techniques. But at the base level, it's a way to generate images. And if you've seen AI art out there on Twitter or other areas, these deep fakes too, some of them leverage this technology already. And so it's really a very interesting way, inspired by diffusion in physics. So diffusion in physics was, how do things diffuse? Let's say particles in the air, how do they move? This is a little bit inspired by that, but it's all about how do we predict an image based off of noise. And so at the root level, it's understanding how do we create images that look realistic, that look like they belong. And for us, it's could we control this really cool engine so that it's not creating something crazy and doing something that's actually useful. And maybe you've seen AI pictures where people are like, oh, you can tell it's AI because the hands are all messed up or the faces are all swirled. That is diffusion. And those are some older iterations where those problems existed, but it's starting to get so good that it's very hard to tell the difference. And our customers, they find a very hard time figuring out which is real, which is synthetic. And that's good for us. You're just supposed to mix those and see what you get.
Awesome. All right. Well, so now what's next for Advex looking ahead?
For Advex, the mission here is to improve the efficiency of the entire industrial base that we see. And for us, our customers scale really quickly. And so what we're actually becoming is more than just a way to make vision faster. It's also a central point of intelligence. Because if we're in all those cameras that are on all your lines, and all your robots are using us, all your defect detection systems are using us, we're getting this whole host, this view, this overarching view across all your operations. And that's something that if it's on premises, you can put all this data together and uncover insights that are really hard for other systems to find, because this is a system that's interdependent. We're coalescing all this information across different processes. And one interesting example was we noticed that when, let's say, process A was producing at slightly slower speeds, then process B would have a defect rate that was nearly double its normal. And that's something that maybe you can find, the defect rate was double, but linking it back to the root cause would be very difficult if you didn't sort of collect all this information. And so one of the big visions here is, how do we become the central nervous system almost for these manufacturers so that they can wake up every day, look at this platform and say, I understand how all my processes are interlinked, and get down to the root cause of some of the more complicated process efficiency matters that they face.
And in the meantime, I mean, from just a basic standpoint, it's like the more data, the better, right? The more you can gather, the more you can keep gathering, the more that everything will, the more you'll be able to learn, and the more that it'll feed that central nervous system.
Exactly. The more data that goes into it, like it can almost model all of your entire processes and understand, oh, something went wrong here, or this is actually performing better. Let's figure out why, so you can implement it across all your systems, even if it was made better on accident.
Excellent. Okay. Well, Pedro, I want to thank you for taking the time out of your day to join us. Definitely some interesting stuff happening with Advex. If listeners want to learn more about Advex, where should they go?
Absolutely. So our website, www.advexai.com. And one thing to note is, I mean, here, what we really believe we're solving one of the hardest problems in AI, data, for one of the most fundamental industries in the world, manufacturing. Right? Manufacturing is absolutely everywhere. And I know this podcast knows that very well. And it's not easy. And solving these very hard things for a very big space is quite hard. So we're hiring constantly across engineering roles. So if anybody is interested there, please visit our website.
Excellent. Okay. Thank you. And to stay up to date with what's happening in manufacturing today and to hear more podcasts, visit us at advancedmanufacturing.org.